All right, so we've got Akshay. I will turn his screen on. Take it away.
Hello. Hi, everyone. Welcome and thank you for joining. I hope you are wearing waterproof clothes. Um, I'm Akshay Chordiya. I'm based in Berlin, Germany. I work as an Android developer at Flow, which is a female health company. I'm also a Google developer expert for Android. So today we are going to talk about something which many people are excited about, that is Kotlin Flow. The goal of this talk is tell you why Kotlin Flow was designed, some basics, show what makes Kotlin Flow so special, and how you can migrate to Flow, and the most important part, testing. So before that, let's rewind a little bit and see what Kotlin gave us. That is coroutines. Coroutines simplify asynchronous programming in general and especially on Android. Here is an example of a suspend function called showUser, which internally loads the user from the database. Since it's a suspend function, it will run on the background thread. We use the with context function, which allows to switch the thread inside the suspending function and change the thread to main thread and call the render function. And that's it. That's how easy asynchronous programming is with coroutines. So this is how it will work internally. We start by calling the show user function. Since it's marked as suspend, it will switch to a background thread or the thread specified while launching the coroutine. And the user object will be loaded from the database on a different thread, while the main thread continues to go ahead without waiting for anything. That is not freezing or blocking the user experience. And then it will switch back to main thread because of the with context, and then call the render function on the main or the UI thread. One key thing to remember is a suspend function can only be called from another suspend function or a coroutine scope. A coroutine scope is basically something which represents the scope of the coroutines. Each coroutine needs a scope to run in, and when the scope is destroyed, all the running jobs inside the scope are also stopped or cancelled. This scope is generally associated with a lifecycle scope for simplicity. For instance, on Android, each activity has a lifecycle. And so the scope could be associated with the lifecycle of an activity. So let's look at an example to help understand this better. For example, in order to call our showUser suspend function from a normal function, we would need a coroutine scope. On Android, some general scopes are already defined for us, like the lifecycle scope. And this lifecycle scope is actually a part of lifecycle KTX library from Jetpack components. It is provided to use coroutine function in activity or fragment. It's a coroutine scope which is tied to the lifecycle of an activity or a fragment. This provides the magic of automatically clearing or cancelling all jobs running in the specified scope when the activity or fragment is destroyed. The launch function is used to start the coroutine. It will immediately start the coroutine. That means coroutines are hot in nature. This is also one of the reasons why coroutines are not exactly one-on-one replacement for reactive streams. A coroutine scope is kind of a subscription management system associated with the lifecycle. This concept is called as structured concurrency, and this is what makes Kotlin coroutines so powerful and also helps developers prevent leaking the job or subscription. So let's look at like what makes Kotlin Flow so special. Well, there are like so many other reactive libraries out there. Let's look at what's so special in Kotlin Flow to raise the bar. So Kotlin Flow provides null safety in the stream. That means you cannot send null values in the stream. This is not something new. RxJava 2 also has it. Interoperability is one of the key thing. Flow provides an easy API to convert Flow to any reactive stream like RxJava Flowable and the reverse. You can also combine Flow and coroutines. So we'll see how to do this later. It also supports Kotlin multi-platform. That means you can use Kotlin coroutines and Flow on any of the Kotlin supported platforms like JVM, JS, or native, or you can put it in the common code or the shared code to use it in your Kotlin multi-platform projects. Plus, there is no special handling for back pressure. Like there are like very few operators, or I think like you don't need to do anything special basically and so this is more or less magically handled by the suspending nature of coroutines. Also, there are like very fewer operators, which directly correlates to ease of understanding. This is because of two reasons: because of Kotlin's extension function magic, and the second is suspending nature of coroutines allows having the same operator to perform synchronous and asynchronous code, which cuts down the number of operators automatically. Also, we saw structure concurrency. It also has the perks of structure concurrency. So, what is flow? So flow is based upon the reactive stream specification, similar to RxJava 2 and some of the popular libraries out there. You can think of a flow as very similar to a list or a collection. Since it's very similar to list of collection, it also has operators like map, switch map, etc. It is built on top of coroutines. We will see that later, and it's cold in nature. So let's look at some of the basics of flow. So essentially, like, there are two components, that is emitter and collector, where emitter emits new values and collector receives those values. Here is an example of an emitter. So this emitter returns flow of string, very similar to how you would return a list of string. And there are various ways of creating a flow using something called as flow builder. They are functions provided by Kotlin Coroutines library. It internally creates the flow for us. We'll come to it later. Since flow is cold, nothing inside the flow builder block will be called until there is a subscriber or a collector observing the flow. Yeah. So let's look at the collector. Here we have the main function which gets the flow inside the run blocking function. For people who haven't used coroutines, run blocking function is a blocking coroutine scope that is blocks the current thread until everything is completed. We need the coroutine scope since the collect function is a suspending function. So is the emit. We will see why. So before that, let's look at how things internally work. So initially, the main function calls the stream function, which will immediately return the flow. Then we will call the collect function on the flow, which essentially means we are subscribed to the emitter. And then the emitter will start emitting the value sequentially, and the collector receives them and prints in this case. And the same loop happens, and it keeps on emitting next values and printing them, and this goes on till the emitter has no values, and that's when the execution moves out of collect and is complete. Let's dive a little bit deeper and see how things are working internally. As I mentioned before, flow is based upon two components, a collector and an emitter. Essentially, they are interfaces. The following represents the interface for emitter, which exposes the collect function, and the emitter function, which allows emitting values. The key thing to note over here is both the functions are suspend, which allows the magic of interoperability with coroutines and also allows using structured concurrency provided by coroutines. The funny thing is the whole mechanism of flow is essentially emit and collect function calling each other. So flow loves coroutine also because it's built on top of it. So let's say you have a function which loads some data from database. Since this function takes time to perform, you would ideally want to do it in the background thread by marking it as suspend. And the funny thing is you can just directly call any coroutine function inside the flow block. That's because the flow block accepts a suspending lambda, and also because both the collector and emitter a suspend function, which is just great. Let's look at the core ideology of flow and how they make our life easier. With flow, you can define or switch the thread by using an operator called as flow on, which takes in a dispatcher, which in this case is IO. This operator sets the thread only upstream. That is, anything above the flow on operator will run on IO thread. The map operator below the flow on will run on some different thread, which is not IO. This concept of preventing context from leaking is called as context preservation, where the context is encapsulated and it's never allowed to go downstream. So there is basically only one way to change the context of a flow. If you compare this to RxJava, where it's like super confusing, especially for beginners to understand which thread their code is going to run on. In the example above, you can see that only the first subscribe on is applied and the other one is ignored. Combined with another operator to change thread, that is observe on, with different behavior, it's a face palm moment. So exception transparency. This is the second principle or ideology of Flow. Flow implementations never catch or handle exceptions that occur downstreams. They catch only for upstreams. This is again due to context preservation, which we saw earlier. There is only one operator to catch error, which is catch operator. Seems obvious. Let's look at an example. So let's take the previous example of a flow which tries to get the value from the database and emit. As you can imagine, anything can happen while the data while loading from database, and which might throw some sort of an exception. Very similar to try catch block, Flow has a catch operator which will catch any exceptions thrown above. You can even use the classic try catch block. It will behave exactly the same as the catch operator, but I would recommend to use the catch operator. But there can be use cases where you want to use the classic try catch. During those cases, just make sure to ignore the cancellation exception, because you don't want to emit an error when your flow or coroutine was uh, cancelled because when the activities are closed or something. This is pretty much how the catch operator actually works internally. So cool. Or you can specifically handle the exception which you want to see. For example, in case of database operation, you would specifically want to catch IO exception, then that's fine. The value oops. Yeah, the value emitted from the catch is received in the collect. That means there is only one single place to handle all types of cases, either success or failure, which makes it super transparent to handle all the cases. I would recommend to toss in skill classes so you can always cover all your cases. So it might be confusing to understand at this point when to use flow and when to use suspend. So use suspend for one-shot operations like insert operation or a network operation to your backend, and use flow when there is a stream of data involved. For example, getting data from the database, so that you can continuously listen for updates. So moving from legacy code to flow. So the idea is to like set up a process with the team. So setting up this process is super important so that the whole team works towards a single goal of migration. So the first step would be is to discuss with your team, like set up a meeting, discuss with your team what are the possible alternatives you would like to work on to move your legacy code to on, like RxJava 2, 3, or Flow. Discuss the pros and cons and all the options and try to get comfortable with your team. It's also important to evaluate how hard the migration of certain options look like for your code base, the learning curve for new joiners, etc. Then set up the guidelines with standard practices, so that the team follows the same standard practices throughout the code base. Also in this step, like set up the necessary base classes for your code base, so that and the architecture, including the dependencies and etc., so that the team is not blocked. Also set up some safeguards. This is like ensuring that the new code, you can set up safeguards like ensuring that the new code is written using Kotlin Flow while doing PR reviews. Other approach is like ensuring that when legacy code is touched, the developer has to try to convert it into coroutines or flow, and some other ideas which might pop into your brilliant mind. The fourth one which we're focusing is interoperability. So this is one of the coolest thing. I love it a lot. Flow provides an amazing API to convert any legacy callback based API to Flow. Let's say you have a function which has a listener, and this listener is triggered each time the document is updated. So you also need to make sure to remove this listener when the component is destroyed, for example when the activity is destroyed. So Flow provides an amazing API called as callback flow, where you can write the legacy listener, that is aka your callback, and offer, which basically means emit this value each time the database is changed. But at this point you will be wondering, like, you also need to remove the listener at some point, right? So you can so Flow provides an amazing function called as await close, which is called when the flow or coroutine is cancelled, where you can safely remove the listener. So let's also look at how you can migrate from Rx to Flow. The goal here is to not tell you to go next moment and migrate your code to Flow. I mean, that would be great for your own projects, obviously. Okay, but Flow and Rx follow the same reactive stream specification. So in theory, it's very easy to convert data streams from Rx to Flow and the reverse. So there are like two ways to convert. First one is like to just refactor your Rx implementation to use Flow, but that's time consuming, and sometimes you would want to just switch the types so that you can gradually move to Flow. In that cases, you can use the as Flow extension function uh, to quickly switch the type from flowable or observable to Flow. And similarly, the same can be done to convert Flow to observable or flowable whenever you need it. Here's a quick comparison of terminology between Rx and coroutines, which I stole from Clue's documentation. In my defense, I created this table at Clue, so I can steal it. And so use this chart as a reference when you're new to coroutines world or working on migrating from Rx to coroutines or reverse. Um, you can see that we have covered pretty much all the things mentioned except channels. But yeah, we can see that later. So let's look at something really fun. The as flow function, which we saw before to convert flow or an observable to flow, actually uses the callback flow internally to convert the observable to flow, which is so cool. If your code base is stuck with RxJava 1, you would want to move away. I would recommend to migrate to Kotlin Flow rather than migrating to RxJava 2 or 3. Since RxJava 1 bindings are not officially supported, I have created a library for those who need it. The link's down there. So it offers this API for RxJava 1 types to convert to coroutines, and also API for flows and observable, almost similar to the RxJava 2 which we saw before. Now to the everyone's most favorite topic, testing. Testing flow or coroutines is pretty easy. Let's take an example. Let's take a simple flow of string and write that test function and use the run blocking coroutine scope, because we want our test to wait till the coroutine is completed. So like I said, flow is very similar to a list or a collection. So you can use the take operator to pick the first value from the stream, and then convert the flow to list so that you can easily assert it. There is also actually flow.first, so you can actually just directly get the first value. And this way you can easily assert. Okay, conclusion. So we saw a lot of topics, but to conclude, like Kotlin Flow raises the bar and makes reactive programming easy. It gives us like great Kotlin feature and like extension functions and coroutines. Like it's a combination, makes it like super nice. That said, like Kotlin Flow is like still a lot in work progress, and it's actually stable. You can use it right now in production. We are using it. But a lot of things are in progress, and bunch of exciting things are coming soon, like shared flow and stuff like that. Thank you.
All right. Thank you very much. That was excellent. We do have some questions. Let me get over to that. All right. Let's see. We covered the swim trunk questions. Can you explain the hot versus cold terminology?
Okay. Yes. So essentially, like to explain it in a very simple manner, like you would think of hot something. Hot is something like as soon as you call it, it will immediately be executed. While cold is something like it will be only be executed when someone is like subscribed, or when you are like someone is like listening to it, or someone is waiting for it, and so it will be like executed when it's ready. So essentially, it's something like that.
Oh, okay. All right. Can you explain the no special handling for back pressure? Is this in terms of threads?
Yes. So since since the whole Kotlin Flow mechanism is built on top of coroutines, so which can handle synchronous and asynchronous code. So that means that you don't need to always. So back pressure essentially means that you're emitting values too fast, and since coroutines can handle asynchronous nature too, they can handle the back pressure pretty much magically. But you can also like still give it certain settings that you to drop only the latest values or something, but you don't need to always keep in mind to handle the back pressure. That's the beauty of Flow.
Gotcha. Let's see. We got time for one more, and then Akshay will be in Slack to answer the rest. when exactly does the link between the emitter and collector is cleared up?
So it is cleared up when the coroutine scope is cleared, or when the emitter is out of values.
Gotcha. All right. Well, thank you very much.
Thank you.
Like I said, Akshay will be in Slack, so feel free to keep asking him questions there and tell him how much you liked his talk. We've got 10 minutes until Ash's talk, so